So let's try and explain the shortest paths algorithm with this example here. So suppose we're trying to get from 1, we want to find all the shortest paths between 1 and 6 here. So our start is equal to 1 and our end is equal to 6. So let's see what the algorithm does. So our begin here, so our done is going to be false. Begin is going to be just the set, the list with just 1 in it. So that's begin. So path so far is just going to be the set with just begin in it. So path so far is going to be the set with just 1, with that only one path in it. So that's begin, and that's path so far. So if end equals start, return path so far. Well, it's not. But if end was 1, then that would be the right answer. All the paths from the shortest path between 1 and 1 is just 1 on its own. Great. So what do we do next? Already visited dot add all new already visited. So already visited will just be that the set 1, 2. 1 as well, I should say. So that's this thing here is begin. This thing here is path so far. So far. And this thing here is new already visited. And then so here, already visited dot add all new already visited. So already visited is also going to be the set with just 1 in it. Path so far becomes next path so far end. So we have to look to see what next does. So what does next do? Well, we set k to the empty set, and then for all paths in the set paths, we add all nexts, paths, and then that's calling the other next. Well, there's only one of these things to consider. This one here. So let's see what the other next with a single list does. So that's this one up here. So this is where most of the work happens. So we set k to the empty set, and we set the neighbours to be the neighbours of last. Last is the last element of the path. So the last is 1 because the path has only got one element. So its last element is the 1. So the neighbours of 1 are 2, 3, and 4. So that means nays is now the set 2, 3, and 4. So what's happening now? So if nays contains end, if not neighbours contains end, well, end was 6, so neighbours doesn't contain end, it's 2, 3, 4. If already visited contains, for each of the neighbours, we're going to add k. We're going to add k to the we're going to add each of the elements of neighbours to our path so far and add it to the set. So what we're going to end up, this thing is going to return k is going to be the value 1, 2, 1, 3, and 1, 4. So this set is now going to be the set 1, 2, 1, 3, and 1, 4. And new already visited is now going to be 2, 3, and 4 because each of those neighbours we added to new already visited. So now we go back to this loop again. So the paths so far are now going to be the result of calling that function. So now paths so far will be 1, 2, 1, 3 and 1, 4. So done hasn't been set to true, so we're going to add 2, 3 and 4 to already visited, and now we're going to find paths so far for these three things. So we're going to go 3 times for each of these paths. We're going to find the nexts of that. Well, for this first one here, because the only next is going back to 1, we can go 1, 2, 1. Then that's not going to add anything. Similarly for this one, that's not going to add anything. But this one here, we're going to add the 6 and the 5. But because one of these neighbours, 6, is equal to end, we'll stop with the paths 1, 4, 6. So our shortest paths, in that case, the neighbours will contain end, and we'll add that path to end, and done will become true. So we'll now come out of this loop here and return shortest paths, which will just in this case give us the set 1, 4, 6. So this program stops us, this algorithm stops us visiting places that we've already visited, and it'll find, because we're doing a breadth first search, we're finding the path with the smallest depth from where we started. So it'll be the shortest path between 1 and 6 in this case.